Good morning, dear students, and welcome to Science 1211, Principles of Chemistry. In today's experiment, we are going to attempt the physical separation of an heterogeneous mixture. In the test tube you are looking at this moment, we have an heterogeneous mixture which is made out of sand and salt. We are going to separate them using physical methods and based on the fact that they have very different solubility in water. We will start the separation by dissolving the sample in water using heat to assure that all the salt is dissolved in the water. At that point, what we're going to have is a solution in which the salt is already dissolved in the water, and we have a solid residue, which is the sand. At this moment, we are going to proceed with a filtration. In this filtration, in the filter paper, we are going to isolate the sand that then we are going to dry and weigh. With the supernatant, what's going to happen is that we are going to heat it to evaporate all the water until the only thing left in the in the beaker is going to be salt. Since we had weighed the beaker before the procedure, by subtracting the weight of the beaker at the end minus the weight of the beaker at the beginning, we're going to have the weight of the salt. The material we're going to be using in this lab is weighing paper to weigh the sample, a porcelain dish which is going to be used to evaporate the sample. Then here we have filter paper, a glass rod, and a rubber policeman, a 100 milliliter graduated cylinder, a beaker with a watch glass that is going to be used to collect the salt and water sample, and where we are going to do the final evaporation. This beaker in particular is very important that we weigh it at the beginning of the experiment, and then we weigh it again at the end of the experiment when the dry salt is on it. The other thing that's important in this experiment is to have at hand all the time a bottle of distilled water. This is what is called a wash bottle, okay? And the water that we have in here is distilled water. The reason we have distilled water is because if you use tap water has some salt dissolved on it, and that's going to add up to the amount of salt we recover at the end of the experiment. And finally, one of the main skills that you're going to acquire in this lab is how to filter. For that, we have this setup in which we have a metal ring that holds a funnel, and this funnel goes to the 100 milliliter beaker that is going to collect the water that we're going to evaporate. Be aware that the stem of the funnel should go down a good deal into the beaker, like about halfway into the beaker, so that you don't have water splashing out when the water drips into the beaker. The data you are going to collect in this experiment has to be written on table 3.1 on your electronic notebook. And that's the table that you're going to use to do your calculations and do the lab report. To use the filtered paper correctly, we have to bend it first in half and then in a quarter, and then take out a notch out of it. Okay? I'm doing this right now because this notch doesn't have to be counted. when you weigh the paper and the porcelain dish. Okay, so for now, just make note in the way how you bend the paper and that you have to take out this little notch. At this moment, we are going to weigh the evaporating dish and the filter paper. For that, we have to turn on the balance and make sure that the balance is 0. If in this display you don't see a perfect 0, you have to press the 0 button in order to zero the balance. Okay? At this moment, the balance is ready to weigh. Place it gently, wait for the weight to stabilize, and as you see, here we have 90.88 grams, and that's gonna be the weight of the filter paper plus the evaporating dish. Next, we are going to weigh our sample. For that, we're going to use weighing paper. For the sample to be retained on the paper, it's always a good idea to bend it in 4, okay? So that it makes like a little basket, like this. Put the paper on the balance, and now that's the weight of the paper, 0.41 grams. But one thing we can do is to zero the balance, okay? And by zeroing the balance, what we're doing is getting rid of the weight of the paper, so that whatever we weigh now is going to be just sample. That process is called TARE, T-A-R-E. We weigh the whole sample, and that's 1.97 or 98 grams. You see, there is an uncertainty on the second decimal, and that uncertainty is okay. It's uncertainty of this balance. So we have to record the weight with 2 decimal digits. After recording the weight, 1.98, we take the weighing paper with the sample and transfer it completely to the porcelain dish. Make sure that all the sample is being transferred to the evaporating dish. We clean the weighing paper with distilled water. Okay? At this moment, we pour the amount of water that your experimental procedure asks for on top of the sample, and now this sample goes to the heating plate. Okay. Now the sample is in a hot plate, and we took the temperature, measuring it with a thermometer. We took the temperature of the sample, or the water, to 60 degrees centigrade. With the steering bar, what we're going to do is remove the sand so that any sodium chloride that might be trapped within the sand, it's liberated and dissolves on the water. Okay? After doing that, don't take the rod right away. Clean it up with water so that any water and salt that sticks on the rod gets back to the original solution. So that way you don't lose material. While the sample is being dissolved, we are going to weigh the beaker and the glass, the watch glass. before we do that, remember always that you have to zero the balance. Okay, now the balance is 0, and we weigh both pieces of glass, and they come out to weigh 83.63 grams. Okay, lab notebook.
Okay, cool.
At this moment, the same paper that we already weigh with the evaporating dish is being wet with water, and we just settle it within the funnel and press it against the walls of the funnel. By doing that now, I'm wetting it a little bit more. The idea is that we create a seal between the paper and the glass. That seal is going to create a water column. As you can see here in the stem of the funnel, the water gets retained. And because it gets retained, now the filtering is a lot quicker. If you don't do the water column, what's going to happen is that the filtration process is going to take forever. Okay? So make sure you do this. This is called creating a column, a water column. And the creation of the water column is achieved when you can have a little bit of water retained on the stem of the funnel. Okay? After the funnel with the paper into the filtration setup. Ready to filter the sample, okay? Remember, we have in the water, we have the salt that is dissolved in the water, and then here we have the residue of sand that is going to get trapped on the filter paper. To do the filtration in the correct way, we have to grab the dish like this, okay? So that when the water runs out, it will go through the rod and will not spill out, okay? So here we go. You see how it's filtering very quickly. And now that we have removed all the water with the sand, we wait for the level of the water on the filter to go down, and then using the wash bottle, the minimum amount of water, wash out the sand so that it falls on the filter paper. Like this. Okay. Rinse it a little bit and let it fall. Don't use too much water. The more water you use, the longer it's going to take to evaporate it. And that's about it. This is the filtration process. So we're going to wait now until all the water goes through the filter paper, and then we're going to wash out with a little bit of water after the sand is left alone. Okay, so the next step is with a forceps, see that the sand is already without water. It's still not dry, it's wet, okay? So just pull out the sand with the filter paper and put it into the evaporating dish. This goes to the oven. The oven is set at 110 degrees C, and the sample is going to be there for about 20 minutes. The filtrate, which will be the sodium chloride solution, needs to go to the heat plate together with the watch glass. Remember that when the sample is put on the heat plate, it needs to be covered at all time, because what's going to happen is that the water is going to start to boil and splash, and the watch glass is going to avoid for spills. Okay, so keep it there all the time. And now we set the heat plate to a high position for the water to start boiling. Here we see that still we are evaporating the water. Don't worry if you see a violent boiling of the water. That's why we have the watch glass on top of it. Okay, so leave it there until you see that the beaker is completely dry. The sand sample with the filter paper and the evaporating dish must be dried already. So we are going to take it out. And set it on the table until it cools down. You can see that the sand is completely dry. Okay, it doesn't stick on the paper. That's the way it should be. Important that you let it cool down to room temperature before you weigh it. If you don't do it, the weight that you're going to obtain is going to be slightly lower than the real weight of the assemble. Okay, so be patient and let it cool down to room temperature. We can see now that it looks like the beaker is completely dry. However, you can see that there is a drop of water on the watch glass. We have to wait until that drop of water is gone. Okay, to assure that there is no water left, because if not, we're going to be measuring water as if it was sodium chloride, and we'll get a larger value of what it's supposed to be. So be patient and wait for that water drop to go away. Sample is already dry. The evaporating dish is at room temperature, so it's ready to be weighed. Okay, but still, even if it's at room temperature, use a plier or a forceps to carry it around the lab. Okay, always put a hand under it so that you avoid accidents. The reason you carry it with the forceps is to avoid putting grease on the evaporating dish. Okay, the grease of your fingers will stick on the evaporating dish, and that will increase the weight. So it's a good practice that always on the lab manipulate the things that are going to be used or that are going to be weighted using forceps and not touching them with your hands. Okay, now we zero the balance and get the weight. The weight is 91.85 grams. Okay, now you can see that the beaker and the watch glass are completely dry. Turn off the heating plate and leave it there, cooling. Don't take it out right away, because the beaker is very, very hot, and if you put it in a cool surface, it may break. Okay, because of the abrupt change in temperature. So leave it there to cool down. The beaker now is at room temperature, So we are gonna take it, go to the weighing station. Okay, the balance has been 0 already. So we proceed to weigh the salt together with the beaker and the watch glass. And the weight is 84.85 grams or 84.59 grams. Okay, let it settle. So 84.59 will be okay. Okay, so we finished the experiment, and as we predicted, we have now pure sand and pure salt. Originally, they were mixed together, but we have proved that by physical methods like difference in solubility and filtration and evaporation, we can separate two completely different substances. Next step is to go and do the required calculations to finish the experiment. This is the table we said we were going to fill up at the beginning of the experiment. Okay, following the letters that we have there on the table, we come back to the whiteboard and we can see that the mass of the evaporating dish and the filtering paper was 90.88. The mass of the beaker and the watch glass was 83.63. The weight of the sample, the mixture that we had at the beginning, was 1.98. And at the end of the experiment, the mass of the beaker plus the watch glass and the salt was 84.59. The weight of the evaporating dish plus the filtering paper plus the sand was 91.85, and by difference between E and A, we calculated the amount of, in this case would be F, which is the mass of the sand. So we recover 0.97 grams of sand. And in G, we have the difference between D and B, which will be the amount of salt we collected at the end, which is 0.96. We can calculate now the percent of recovery by adding up the sand and the salt that we recovered and divided that by the original mass of the sample multiplied by 100. And we get 97.5%, which means that we collected 97.5% of the original material that we had in the sample. Of course, the 2.5% are losses on the experiment. Those losses can come from error in weight. It can come from water that splashed out of the beaker. There are a lot of factors that can influence that result. But normally, this is a very good result, okay? On top of that, if we now take the amount of salt divided by the amount of original sample multiplied by 100, we can say that in the original sample, 49% of that sample was salt. And by taking the amount of sand recovered divided by the original weight of a sample multiplied by 100, we get 48.5, which is the percentage of sand we had in the original sample. With this, my dear students, we finish this experiment. You have the data now. You have to fill up your lab report and answer the questions that you have in the pre and post lab of this experiment.